All right, so rule is when you're multiplying two functions. Okay, so we've done all the elementary functions, we've done the basic derivatives, but sometimes you're going to do things like 2x times sine of x. And what are you going to do here? Now, naturally, you might think, oh, I just do the derivative of this one times the derivative of that one. Unfortunately, that doesn't work. That's not how it actually operates. There's actually a more complicated rule, and product rule is used for that. And we can actually use the limit definition to show you why this rule works, right? So if I have a function f of x times g of x, and I wanted to do the limit as h approaches 0, and I want to do the product, so this would be f of x plus h times g of x plus h minus f of x g of x. So this is me just doing the limit definition of the product of two functions here, right? F times g, right? That's all I'm doing here. And you might say like, okay, so how can we derive like what to do here? How can we make it look like in terms of f of x plus h and f of x and things like that? So the trick we're going to do is do a little bit of tricky manipulation and factoring, and I'm going to move it down here so we can have it nice and simple here. So what we're going to do is we're going to, and this is just a trick, right? Just to prove the derivation, but we're going to subtract an f of x times g of x plus h, but I can't just subtract that. If I add it back in, okay, so what happens here is if I add it back in, then it's like I added 0 because I'm like this expression and this expression are the two same things. Now what I can do is I can group this guy with this guy here. So we're just going to rewrite the numerator a little bit. F of x plus h, g of x plus h, okay, minus this part here, which is f of x, g of x plus h. So that's the green part there, right? And now we're going to group these two guys together in purple. And I'm going to write it in a very specific way. I'm going to write this one first. So plus, and I'm just going to split it as separate fractions, which I can, right? Like that's totally fine. X plus h minus f of x, g of x plus h. Oh, sorry, f of x, g of x, right? Like that. Cool. So then if we look at this, we notice that on here, I can factor out a g of x plus h. This is a g of x plus h. And then if I factor that out, what I'm left with, and I bring it out in front, this is going to be f of x plus h minus f of x over h. And then on this guy, what can I factor out is I can factor out an f of x, right? There's an f of x on both of them. So we can factor out an f of x and then get here g of x plus h minus g of x, right? That's what I have left, divided by h. And notice, if you look at some of these things here now, this guy right here is f prime of x, as long as we do h approaching 0. This guy is going to be g prime of x, right? G of x plus h minus g of x. So it's going to look just like that from our limit definition. And then if we evaluate h equals 0, that will just be 0 for that guy. So then this ends up being g of x times f prime of x plus f of x times g prime of x. Okay, so this is the derivation here. And this is what I wrote up here. This is our formula. Now, you don't need to derive it. You just need to know that you're going to do f prime of x times g of x plus f of x times g prime of x. You don't do the derivative of them separately. When I'm multiplying two functions, I got to do, and the way I like to remember it is, I do the derivative of the first function, but I leave the other one alone. And then I swap it. I do the other one alone and then times the derivative of that function there. So let's take a look at some examples of how we would do it. And a lot of times you have to do it symbolically on the AP exam, not just a computational thing that you can do in your calculator, but symbolically. So let's do it with some functions like here. So let's take a look at this. We have x times x squared plus 3x. So that's my f, that's my g. Okay, so f prime of x, it's not really the same as f, and it's a little bit confusing, but this is the first function, second function. So derivative of x is 1 times the other one unchanged plus x, this one unchanged, and the derivative of that guy, that's going to be 2x plus 3. Right? And so that's going to give you x squared. If you want to simplify, you don't have to simplify. X squared plus 3x plus 2x squared, distributing the x there, plus 3x. And that would give me 3x squared plus 3x plus 3x is 6x. Okay, so that would be like that. And there's other ways you could have done this derivative. You could have distributed the x first and made this x cubed plus 3x squared. And then when you take the derivative of that, I'm going to get 3x squared plus 6x. Right? So same thing. That would have been a faster way to compute this derivative, but wanted to show you how this operated. Here's another one where we're multiplying two functions. Derivative of the first function. So when I always think a derivative of the first function is 1 times the other function unchanged plus x, and the derivative sign is cosine x, right? Just like that. Here, let's take a look at something like this. Ooh, here we got to do a few things put together. We got this. These two are both products. So remember, we're going to do this one first because you're adding or subtracting another function. We'll just do that one second. So what's the derivative of the first part of this function is going to be 12t squared times the other function unchanged. And then 4t cubed, that unchanged, times the derivative of e to the t, which is just e to the t. Okay, so that handles that first one, and then we're going to do minus, and we're going to handle this guy right here. So we have this minus sign, and now we handle that. Because remember, when we add functions, we just take the derivative of each one, adding them up. It's just when we're multiplying functions, we cannot just do the derivative of them separately. We got to do the product rule. So derivative of sine is cosine times this one unchanged. Then the derivative of then times plus sine, and the derivative of cosine is negative sine. And so that will be our expression. You could simplify that if you wanted to, but honestly, that is the derivative portion. That is applying product rule. Sometimes we've got to look at graphs or things like this. So the graphs of the linear function f and piecewise linear function g's are shown. H of x is f times g. What's h prime of 3? Well, h prime of x, first we compute the derivative. H prime of x would be just using our product rule. Derivative of the first one times the second one, plus the first one times the derivative of the second one, right? Like that. So h prime of 3 is going to be literally plugging 3 into this expression, right? So first I always get the expression, and then I plug in values, right? So then we say f prime of 3. Well, what's f prime of 3? F prime of 3 is the slope at 3. At 3, the slope looks like it goes over 1 and down 1, right? Over 1, down 1. So that slope here is negative 1. F of 3 is the y value at 3. That's 4. So this value here is 4. How about g of 3? So let's look at g of 3. G of 3 is the y value here. G of 3 is 3. The y value is 3 there. And because it's g of x. And then now we want to know the slope at 3. Well, this is a straight line. It goes over 1 and up 2. So that's a slope of positive 2. Right? So then we put it all together. We get negative 1 times 3 plus 4 times 2. So that's going to be negative 3 plus 8. And that's going to be 5. Okay, let's look at another example. Very similar example, right? We're going to do almost the exact same thing. Just to so you see it again. G of x plus f of x, g prime of x, right? And then we're just going to plug in 4 here. That's going to be f prime at 4, g of 4, plus f of 4 times g prime at 4. Right? And so we want to look at that. So we want to say like, okay, so at 4 is the x coordinate here. Let's see, this line is f of x. So f of 4 we know is 2. The y value is 2. But the slope is it goes over 1 and up 1, it looks like. So that's a slope of 1. G of 4 is 1. The y value is 1 there. And then the slope is you go over 1, 2, and up 1, 2, 3. Right? So 1, 2, then 1, 2, 3. So it goes over, it's like 3 halves, right? Rise over run. So this is going to be 1 plus 3, which is going to be 4, right? 1 times 1, 2 times 3 halves, so it cancels. That'll be 3. 1 plus 3 is 4. Sometimes you might be given a table and a combination of things. Let h of x equals 2x f of x, where f of x is a differentiable function. Selected values of this are given on the table. Compute h prime of 2. So first, let's compute h prime of x. We're multiplying two functions. We're multiplying 2x times f of x. So we do the derivative of 2x, which is 2, times f of x, plus 2x, this unchanged, times the derivative f of x, which is just f prime of x, So then we plug in 2 here. It's going to be 2f of 2 plus 2 times 2, f prime at 2. Right? And so what's f of 2? F of 2, look at the table, that's 5. So this value here is 5. What's f prime at 2? Negative 2 here. And so this is going to be 2 times 5, which is 10. And then this is 2 times 2 is 4. 4 times negative 2 is negative 8. So I'm going to get 2 there, just like that. Thanks for checking out this video. I hope you found it really helpful. If you'd like more support, maybe you need more multiple choice practice, maybe you just need more guidance and things like that, I have plenty of information on my website. If you look in the description below and go to www.bothellstemcoach.com, I will explain all the ways I help students be successful in their AP classes.